Hello and welcome to Sean White's Solar and Energy Storage Podcast. In this podcast, we're going to learn about lithium battery topics. Some of the topics we're covering are transportation of these batteries, lithium metal dendrites, lithium ion batteries, International Air Transportation Association rules, that's the IATA, surprise thermal events, recycling of lithium batteries, battery aging, rock content, cutoff voltage, battery sweet zones, stratification, battery fading, second-hand EV batteries used for stationary energy storage systems, and data science. On with the show. Hey folks, we're going to talk about some interesting things about batteries and energy storage systems. So let's get started. Lead-acid batteries have been the go-to for solar and energy storage for many years. One thing about this though too is now you have to be really careful not to accidentally put a lithium battery that could look like a lead-acid battery on the pallet with the lead-acid batteries, because when they grind these things up to recycle them, it could cause just an explosion. So lithium batteries, folks, they can short out, unlike your alkaline battery. Some information from the International Air Transport Association, air traffic. So the International Air Transport Association has different rules for different batteries. First of all, we have 2 grams per battery for lithium metal. Typically, we're not using lithium metal batteries yet very much because lithium metal batteries are more likely to have something called dendrites forming. And so when these dendrites form, it can short out a battery. As we correct these dendrites, lithium metal batteries are going to become more and more popular because they're better for energy density and specific energy. However, at 2 grams per battery, that's the most that you can do for lithium metal batteries as opposed to lithium ion batteries. So lithium ion, that's typically what we're talking about these days, and that's 8 grams per battery for lithium ion, or we can say equivalent lithium content of 100 watt hours total. That's total 1/10 of a kilowatt hour. And so that's 8 grams per battery, but that would be 25 grams combined for a total of 300 watt hours. So 8 times 3 is 24, so that's about 3 batteries. So we're going for 100 watt hours all the way up to 300 watt hours, which is kind of a lot if you think about what you're going to be traveling around with. That's 0.3 kilowatt hours, 300 watt hours. So we can find out about the International Air Transportation Association at IATA.org, and we can search for all the different specifications about what you can carry to the trade show. If you're going to be displaying batteries and so on and so forth, you're probably not going to be bringing along any large energy storage system to the trade show. So lead-acid batteries gave the battery recycling business a big start. And they say in the recycling industry that lead-acid batteries are the poster child of all recycling. Such a great percentage of lead-acid batteries get to be recycled. One of the reasons is because they have a core charge. So if you swap out your battery at the auto parts store, they charge you a bunch extra and then they refund that when you drop off your battery. That's called a core charge. They can also do that with other parts of the car, like your cylinder heads. That's called a core charge. And of course, the lithium ion batteries aren't even in the same league of toxicity as lead acid batteries, and that's why it was so great to recycle the lead acid batteries. But you could have a lot of energy stored in these lithium ion batteries. So the first part of the recycling process is to make that battery dead. So you just go and you run that battery down so you don't get a surprise thermal event. I would call that an explosion. It's always nice how scientists put it nicely, surprise thermal event. And then other things that they possibly could do is freeze the electrolyte. And there are different ways of doing this. This isn't the only way of doing things. So it's kind of neat how we are recycling these batteries, because lithium batteries are expensive, and part of that expense is going to be the chemicals that make up the lithium batteries. So it's nice that they're recycling the lithium batteries. And once again, I just like to put it out there, these lithium ion batteries that we're using are not nearly as toxic in any way as a lead acid battery. So if you're driving around a gas car, you have super toxic lead batteries and a gas tank full of something that can really explode a lot more than a lithium battery. What happens when a battery ages? A lot of times we talk about rock content. So it's like putting rocks in your gas tank. If you had a gas tank that could fit 20 gallons and then you put 10 gallons of rocks in the gas tank, your gas tank can only do 10 gallons. Kind of reminds me of how some people, I can recall before we had energy efficient toilets, would stick a brick in the toilet tank to reduce the amount of water going through their toilet. That's a good thing to do during a drought. Once in a while when I'm dropping off a rental car, they'll say, "Did you fill up the tank?" And it's like, "Oh yeah, I put a bunch of rocks in there." And they laugh. But hey, I'm sure somebody's done that. But I swear it's not me. So a brand new battery should be able to use 100% of its capacity. And then as that battery gets older, after you start using it, you start getting more and more of rock content. That's the unusable part of a battery. Above the rock content is the available energy. So that's the energy that you're going to be using. And then the empty zone. So with lead acid batteries, it's most healthy for them to be fully charged, topped off, and trickle charging. With lithium batteries, not the case. Those of you that have electric cars know that if you're not going to go on a long drive the following day, it's good to not fully charge your lithium ion battery. You will get more cycles out of it that way. However, there's going to be different car companies or different energy storage companies that are going to have different algorithms. That's a computer program that's going to tell you how much to charge it, if you're going to charge it all the way to the top, which you could do or not. Okay, now we're going to talk about cutoff voltage. So in portable devices, but in batteries in general, if you take a whole bunch of current all at once, the voltage is going to go down. So high current will bring down the voltage prematurely. If you took those batteries that you were discharging really fast and let them sit for a while, then you might be able to use them a little bit more. And this effect is even more so with cold temperatures because that causes resistance, and cells with high internal resistance. So if you took a flashlight battery, it's not going to work as well as a lithium battery. And oftentimes when you have a battery, you might have what we call a residual capacity of 30%. So you might leave 30% at the bottom of the battery when you're fast discharging things. It all depends, once again, on the computer algorithm. These algorithms will tell you how low you can get, and they can also determine how fast you're discharging. Another good thing about having a bigger battery bank is, relatively speaking, on the battery cell level, you're not discharging the battery as fast when you have a bunch more batteries for the same job. So it's not good for batteries to run them all the way down, especially for lead acid batteries. For deep cycle lead acid batteries, people usually only run them down to 50% because if you discharge them below 50%, it really eats at the lifespan of the lead acid batteries. With lithium batteries, they're famous for being able to go down below 50%. And you can run every battery down all the way. It's just not good for its lifespan. And as it gets lower too, you're not going to have as much available current in general. And now we're going to talk about the battery sweet zone. The sweet zone is the place where you like to be to prolong your battery life. The best place for battery life is in the sweet zone. And it really depends on your application and how long you want that battery to last. So for instance, the battery on my phone, I get a new iPhone every year now, and I've noticed that the battery, by the time I turn it in, is going dead every day. And when I first get the phone, it doesn't do that. If I kept that battery in the sweet zone, if they had an app for that, the battery would last much longer, but still, then when I first got my phone, perhaps it would go dead every day because I wouldn't be taking advantage of full capacity. And the people that make the iPhones and the other smartphones, they want you to buy a new phone every year. And that's one reason why they got me to buy a new phone every year, is because of the battery problem that I have. I don't like my phone battery to go dead all the time. So it's your battery management system that's going to keep you inside of the sweet zone. And perhaps you can have emergencies that get you out of the sweet zone. And perhaps also they can change the definition of the sweet zone. You hear sometimes about these electric car companies sending a message to the cars and changing the parameters of the sweet zone. Or in other words, you buy a car and then suddenly you find your range is longer. You can have a longer range by going out of the sweet zone. When you have an electric vehicle though, they're probably not going to let you modify the sweet zone, but they do let you know if you charge the battery to 100%, it's not as good for your battery. And people like their batteries to last for a long time. There's a lot of different things that you can do to make your batteries last longer, and other things are charging it and discharging it slower rather than charging and discharging faster, which is why a lot of people like to charge their batteries at home, because they can do it overnight over a longer period of time, which is better for the battery. And this also goes for your energy storage systems not just your cars. In fact, in a lot of cases, it's the same battery cells that they're using for the energy storage system and the cars. And that probably just has to do with there's so much R&D, that's research and development and technology going into the electric vehicle market, that it's just cheaper for the companies to make a few extra batteries for the energy storage market. And the electric vehicle market demand for batteries is a lot more than the energy storage market. And that's great for all of us because that mass production is bringing down the energy storage costs for stationary energy storage systems. Dang, I can't wait for my car to be able to be an energy storage system when it's stopped in my garage and be able to assist the grid. If you're taking this class and that decision's up to you, come on, make it happen. So once again, they're saying that electric vehicles are seldom fully discharged or charged, and most of the time operate between 30 and 80% state of charge when new. But as they age and start filling up with rocks, they might still keep you with the same amount of energy storage. However, they will change 30 and 80% numbers to deal with those rocks. That's right, the rock content, the unusable part of your battery. So a deep discharge to empty the battery followed by a full charge would cause undue stress for lithium-ion batteries. Another application for lithium-ion batteries, we all have them. They're called satellites. You know, those things up in space, and they just stay in the sweet zone because it's really expensive to change the batteries on your satellite. I hate it when I have to do that. So I stay in the sweet zone. There's lots of crossover between lead acid and lithium-ion batteries. Lead acid is very popular. In fact, even if you have a Tesla Model 3, you have a lead acid battery in there. Isn't that crazy? So stratification is something that you see in the Grand Canyon. That's right, let's do a field trip. Make your reservation. So you have different layers of things, and heavier things will settle towards the bottom, lighter things settle towards the top. And so with concentrated electrolyte, that would go down towards the bottom, and then you would have a more charged bottom of the battery than the top of the battery. And that's just not good to have the charge different on the top versus the bottom of the battery. So if you get a lead acid battery down below 80% depth of discharge and it doesn't receive a full charge, this is going to increase the amount of stratification that you have. One thing about cars, though, is they're bouncing around on the road, so they can help stir up the battery. But if you had a lead acid battery at your house, it's not going to stir up as much. One of the things that you'll do for maintenance with a lead acid battery is called an equalization charge, and it's a controlled overcharge that splits hydrogen and oxygen, and it creates bubbles, and it stirs the battery up. And so these bubbles stir up the battery. They get rid of stratification, and they can also scrape the lead sulfate crystals off of the lead battery plates. So acid concentration is light on the top, heavy on the bottom, and the battery will appear to be fully charged when it's not. Also, excessive acid causes sulfation. That's the buildup of lead sulfate crystals on the battery plates, and that will happen on the lower half of the plates. So we don't like to get stratified, unless you're talking about guitars, of course. And speaking of guitars, let's talk about rock. Yes, that's right. The rock content of the battery is the part of the battery that you can't use. Totally faded battery. That's another term that's good to know. So your battery is faded. It's kind of obvious what faded means. If you have a home battery backup system, is it good to charge it all the way up to 100%? Perhaps if you see the hurricane coming, you might want to top it off. And some batteries can even communicate through the internet and see when the hurricane's coming and then top off your battery. So when you go buy a home energy storage system, make sure that it can analyze weather reports. And don't trick your battery by saying that you live in a different location. If you're near that hurricane, that might be important. And yes, most battery systems don't analyze weather data, but they should. And in the future, it's my belief that they will. One of the things that they are doing with some electric vehicle batteries is when rock content, it can perhaps get too high for driving down the road because you need more range, but it works fine for a stationary energy storage system. So they're using rundown electric vehicle batteries, putting them in warehouses, and still getting a lot of energy storage out of them. So you're turning the energy storage in your EV, swapping that battery out for a new one, and then putting it in a warehouse for a stationary, grid-supporting energy storage system. Data science is a huge industry, and it's getting bigger and bigger. I have a very good friend that's a data scientist that does very well for herself. Thanks for listening to Sean White's Solar and Energy Storage Podcast. To learn more about energy storage, solar, or anything else you want to know, go to solarsean.com. Over and out.